Welcome back to Geometry, Measurement, and Probability. In section 10.4, we're going to talk about measures of central tendency as well as measures of variation. So let's get started. Two very important aspects of data are its center and its spread. The mean and the median are measures of central tendency, so they tell where our data are centered or what would be the most typical value. Our range, interquartile range, standard deviation, and variance describe the spread of the data, and they are used with our measures of central tendency to describe our data. Now first, let's talk about the mean, often called the arithmetic mean or the average. To find the mean, we add all of our values together and we divide by how many values we have. X bar is the notation that we use for our mean. In example 1, we are asked to find the mean number of M&Ms per bag. Our notation for mean is an X with a bar over it. To find the mean, we add all of our values together. And here I divide by 10 because I have 10 values. The sum of my values, and when I divide by 10, I get a mean of 10.2. Look at example 2. Again, we're asked to find the mean. Our notation is an X with a bar over it. It's called X bar. We add all of our values together, and we divide here by 6 because I have 6 values. The sum of our values is 35. Divided by 6 is 5.83. You can think about the mean as the balance point of our data. If I think about the distance between each of my data points and the mean is the balance point, where the sum of the distances of the data points above the mean is the same as the sum of the distances of the points below the mean. So look at our example. Here our mean is 5. First, let's look at our two data points that are above the mean. 8 is 3 away from 5, and 10 is 5 away from 5. 3 plus 5 is 8. Now, look at the data points below the mean. 4 is 1 away from 5. 3 is 2 away from 5. And notice that 3 is used twice, so I add 2 twice. And 2 is 3 away from 5. When you add your points, you get a total of 8. The data are always centered about the mean, but that doesn't necessarily mean that our mean is in our data set. And it's possible to rearrange our data so that they have the same mean, but the spread is different. Look at the next example. Suppose to get an A in a class, a student needs a 90 test average. So far, the student has taken 4 tests, and we have the scores on those 4 tests. Now, the student has one more test to take, and we want to know what grade must that student make on that last test to earn an A. Now, our average here is 90. We're going to add our test grades. So our first 4 test grades are 88, 92, 98, and 85. I don't know what the 5th test grade is, so I'm going to add X to that sum. There are 5 test grades total, so I divide by 5. In the numerator of your fraction, add 88, 92, 98, and 85, and you get 363. Bring down the plus X in the numerator and the 5 in the denominator. To solve the equation for X, multiply both sides by 5. That gets rid of that fraction. On the left side, 5 times 90 is 450. Bring down 363 plus X. Subtract 363 from both sides, and this tells us that the student needs an 87 to get an A in the course. Look at another example. Suppose a company has 25 employees. The mean age of those 25 employees is 45. Now the company hires 2 more employees and their ages are 52 and 34. And we want to know what is the mean age of the employees of the company. Now we don't have the ages of all 27 employees now, but we can use our given information to find that. So first, let's think about our mean. To find our mean, we add all our values together and divide by how many values we have. We know that the mean of the first 25 employees is 45. So notice I added x1 plus x2 plus ... all the way to the 25th employee, and I divided by 25. Multiply both sides by 25 to get rid of that fraction. And the sum of the ages of the first 25 employees is 1,125. Now let's think about adding our 2 new employees. So our mean is the sum of our first 25 employees plus the new employees. We now have 27 employees. The sum of the first 25 employees was 1,125. Bring down the last 2 employees, divided by 27, add the numbers in the numerator, gives us 1,211, and divide by 27. And we know that our new mean is 44.85. Now, our median is our middle value when our data is in order from least to greatest. So to find the median, the first thing we do is we put our data in order from smallest to largest. If we have an odd number of data values, then the median is the middle number. And if we have an even number of data values, we average the 2 middle values. Now, many times the median is reported with the interquartile range. This is a topic that we'll talk about later in this section. And the two together, the median and the interquartile range, describe our data better than just the median alone. Now let's look at finding our median. First, we need to put our data values in order. So we take the heights of the children in Mrs. Jones's class and we list them from smallest to largest. Then we mark off a low value and a high value, a low value and a high value, a low value and a high value, and we keep marking off low and high values until we get to the middle value. And here, our median, our middle value, is 130. The notation that we use for median is a capital M. Let's look at another one. So here in example 6, we have the numbers of M&Ms in 10 bags of M&Ms, and we're asked to find the median value. First, put your data values in order from smallest to largest. Then mark off a value at either end until you get to the middle value. Now notice this time we have 2 values in the middle. So we add our 2 values together and divide it by 2, and we get a median of 10.5. Again, notice that I used a capital M to represent the median. Now our mode is another measure of central tendency that's used. Our mode is our most frequent value. It is possible for a data set to have no modes, and it's also possible for a data set to have many modes. And the mode is frequently used with our categorical data. Now look at example 7. We are asked to find the mode for the heights of the children in Mrs. Jones's class. So I'm going to look at how many times each value is listed. 120 is listed only once. 134 is listed only once. And I'm going to continue looking at how many times each value is listed until I've looked at all of the possible values. In other words, all of the possible heights in Miss Jones' class. 126 is the most frequent, and so our mode here would be 126. Now look at example 8. Again, we're asked to find the mode, but this time for the number of M&Ms per bag. 7 is used once, 9 is repeated twice, 8 is only listed once, 11 is listed twice, 12 is listed only once, 15 is listed only once, and 10 is listed twice. The most frequent values here would be 9, 10, and 11. So how do you know which measure of central tendency is most appropriate? Well, it depends on the situation. Look at example 9. Suppose a company employs 20 people. We have the salary of the president, the vice president, and the 18 part-time employees. And we want to know which measure of center is most appropriate. So let's start by finding the mean. To find the mean, we add all of our values together. The president earns $200,000, plus the vice president earns $75,000. And there are 18 part-time employees who earn $10,000. So notice here I multiplied 18 times 10,000 for those 18 part-time employees. Divided by a total of 20 gives us a mean of 22,750. Now notice that this mean is affected by the really high salaries of the president and the vice president. This mean is much higher than the typical salary. So our mean is not going to be the most appropriate. Let's look at the median. For simplicity's sake, instead of writing 10,000, I'm going to write 10 to represent 10,000, 75 to represent 75,000, and 200 to represent 200,000. Now there are 18 employees who earn $10,000, so I'm going to list 18 tens. Then we have the vice president who earned 75,000, so 75, and the president who earned 200,000, so 200. Mark off a value from either end until you get to the middle value. Since we have two values in the middle, we add our two values and divide by 10, and so our median here is 10, or 10,000. The most frequent value, our mode here, would be 10, or again 10,000. Here, both the median and the mode seem to describe a typical salary, and so either of these would be appropriate for our measure of center. As we saw just a moment ago, our mean can be affected by extreme values, but notice that the median was not. Now, let's look at these scores on the test, and we want to know which measure of center is most appropriate. First, let's find the mean. When you add all those values together, you get 619. There are 9 values, and so our mean would be 68.78. Okay, that kind of describes our scores. Let's look at the median next. Mark off one from either end until you get to the middle, and notice our median here is 92. Well, 92 does not describe a typical score, so the median is not going to be appropriate here. The mode is the most frequent. Our modes here are both 40 and 92. The median is not a typical score, so it is not appropriate. The mean is better, but maybe still not a typical score. And so our mode would be the most appropriate measure of center in this example. Look at example 11. Is the mode an appropriate average for our test scores? Well, our mode here is 98. That is way too high, and so here the mode is not going to be appropriate to represent our typical score. Join me in our next video as we look at our measures of spread.